We're asked in part A to solve a simultaneous equation involving a quadratic. That's if you rearrange the bottom one, you'd get a y equals minus x squared kind of curve. It's going to look like that. And if you rearrange the top one, you'd get a straight line with a positive gradient. And we are finding out where the two of them intersect, which is basically the motivation for our method. It's to make y the subject. In this case, you can make x a subject, but then you get fractions, so much better to do y. Y is 3x plus 2. And because where they intercept, they have the same y values, we can just replace that y there by 3x plus 2. So x squared plus 2 times 3x plus 2 is going to equal 20. Therefore, x squared plus 6x plus 4 is going to equal 20. I can minus the 20 to make it minus 16. Let's see if this factorizes. 8 and 2 jump out at me because they multiply to give 16, and I can see if I do 8 minus 2, I'll get 6. So I'll make this plus 8, this one minus 2, and then it checks out. x1 is 2, x2 is minus 8. Sub in to get y1. Put it back into this one here. That's going to be the simplest thing. So I'm going to get 8. And then y2, if I put in minus 8, I'm going to get minus 24 plus 2 minus 22. You could even, just to be extra sure, put it back into the left-hand side of the bottom equation. So 4 plus 16 is 20. Actually, I don't need my calculator for that one. And then 64, and then it'll be minus 44 is also 20. So I can be 100% confident with that. If you're not too happy with your factorizing, then okay, you've got this button on your calculator, equations, functions, polynomial, degree 2, and you can solve it that way. 1x squared plus 6x minus 16, 0, and we get 2 and minus 8 that way. B, we've got an exponential equation to solve. So we can take logs of both sides. And it's up to you what base you use. I would go with either 3 or 7. In fact, I think I'm going to go with 3 because this one's a little bit more complex. You could go with base 10, but the advantage is, well, let's do it. Log to base 3 of 3 to the 2x minus 1 equals log to base 3 of 7x. We can bring the 2x minus 1 down now, and then it's just log to base 3 of 3, which is 1. So that's the advantage of doing that kind of base. Over here, okay, I'm left with log to base 3 of 7, but it's not too bad. If you struggle with this sort of thing, then what you could do is find log to base 3 of 7. And then like substitute that in, just use enough decimal places. You might just find it easier to solve it. I'm going to do it without because there are questions that will require you to keep things exact. So what I'm going to do is minus x log to base 3 of 7, add the 1 to both sides, and then factorize out the x. See, this is keeping everything exact. It doesn't say to find the exact answer, so we'll be rounding it. So if I had substituted in, let me just say, for this 1.7712, I could write 1.7712x here. And then you'd do the same sort of thing. You would do 2x minus 1.7712, which you can do on your calculator. I'm not recommending doing this method, by the way. I'm just saying, like, if you really struggle, it is an option. 0.22878. Sorry, what was it? I've forgotten. 0.2287, 75. Right, change that time. Okay, and then that's the number of x, and that equals 1. So we're kind of doing the same sort of thing you would do if that was if that was just an x, you would minus x and add 1 or something along these lines, and then x is going to be 1 over 0.22875. One over answer 4.37. Okay, using my original method, you get it exact. I would say like this is the way to go really if possible. And then it's only at this point I'd actually use my calculator 1 over 2 minus, and it's going to be the same because remember that log to base 3 of 7 we worked out in the other one, but we did exactly the same steps, 4.37. Okay, great. Just a final comment, I checked the mark scheme and they actually decided to use base 10. I'm not going to go through the whole thing, but I'm going to show you what they did. So they like this a lot. I think it harks back to the days when there was only a log to base 10 or a ln button on your calculator, so you had no option to do log to base 3. And I guess you could just learn how to do everything in base 10 all the time and just learn those rules. I'm just trying to give you ways to speed things up. But here, log to base 10 has been used. That's the implied by just writing log. Um, so we end up bringing them down, but this now no longer disappears. So there's just a little bit more to it. Um, and in a similar way, they've expanded the brackets and rearranged it. So there'd be a little step in between 2x log 3 minus log 3 is equal to x log 7. We can minus the x log 7 and add the log 3 on. That's where this has come from. Factorize out the x, a bit like what I did, and then divide by it. We get exactly the same answer. So look, it's worth looking at different methods. I've actually now given 3 approaches, like one for if you're really not happy with this kind of algebraic manipulation, one which is the quickest way. This is the best way I'd say, and one which just goes with good old log to base 10.